In this episode, we would like to introduce this multi-car lift system. Unlike the traditional car elevators, it conveys a number of cars vertically and simultaneously within the same narrow lift shaft, which can fit with only one car. Many cities, particularly those highly developed cities, always run out of land to park all the private cars in peak hours. Different types of multi-story parking facilities were thus developed to make a better use of land. However, they all come with different limitations. The traditional multi-story car park rely on ramp connect to each floor. This type of car park usually limits to around 10 floors, as it will be too exhausted for driver to drive from the ground to the roof, and vice versa. Some systems convey cars via elevators or some rotary mechanism. However, such system can only send one car to the ground or up to the parking floor at any point of time. The system also needs to wait for the completion of the loading or unloading process before it can serve the next car. Such sequential process further limits the throughput of the car park and may become disastrous in peak hours. Some car parks deploy multiple lift shafts or rotary mechanism to tackle the issue, but this approach inevitably occupies more spaces on every levels that the lift shaft run. Our design attempts to tackle the issue by maximizing the number of cars that can travel simultaneously inside a single lift shaft and minimizing the loading and unloading time by turning this sequential process into a parallel process. Details will be revealed when we come to the basement where the process takes place. Now, let's start with this lift silo, which is the tallest structure in our design. Although the lift silo appears as a standalone tower in this presentation, it can also be embedded into the core of a much fatter residential or commercial high-rise. The lift silo runs from the roof to the basement. It consists of 3 vertical sections, including the roof, parking, and landing section. The roof section houses the lift machine room behind the advertisement panels. It also equips with fire retardant tank, which is always ready to suppress fire breakout in the parking section below. The mid-section underneath is the parking section, where parking bays are available at both sides of the lift shaft at each levels. This is also the longest section because the longer is this section, the more cars can be accommodated in the parking silo. Going further down from this parking section is the landing section underneath that is protected by Sky Dome. Before we can visit this section, let's temporarily remove all these structures. This landing section is the place where multiple cars are raised simultaneously from the basement into the lift shaft and subsequently be conveyed to the assigned parking bay. From this angle, we can now see the framework of the lift shaft that runs all the way from the basement through the parking section. It is supported by concrete columns which holds guide rails in order to ensure that cars and counterweight can travel smoothly and precisely along the lift silo. In this example, a 4-car system is introduced to illustrate the idea in a simple way. However, depending on the actual needs, more cars and more levels can be added into the system design to further enhance the system efficiency and capacity. The key component that runs inside the lift shaft is this stacker that just step onto the stage. It travels vertically along the guide rails behind the concrete lift shaft and convey multiple cars to their designated parking bay. At each stop, at most 2 levels of pallet where the cars sit can be slidden horizontally and simultaneously from the parking bay onto the stacker, and vice versa. That means in order to load and unload all 4 levels of pallets, the stacker will need to stop twice, as shown in this demonstration. Such an extra stop at loading bay level is due to the difference in level height between the loading bay with the stacker as the result of maximizing the number of parking levels. In the landing section, each level of stacker aligns with the levels of the another key component called lander, such that pallet can be slidden in or out from the stacker. 2 landers which operate independently sit at both sides of the lift shaft at the basement. With the help of a pair of hydraulic pistons, the lander arms that carry the pallet can rotate 90 degrees in order to lower pallets from the stacker onto the ground or raise them to the corresponding level of the stacker. As shown in the demonstration, each pallets that sit on the lander slots can naturally maintain its horizontal position mechanically throughout the pivot movement of the arms. In order to allow the lander arms to rotate freely without hitting the car roof, sufficient headroom above each pallets must be reserved. That's why the level height of the stacker is much greater than the height between parking bays. The landers also split the basement into arrival and departure zone. On arrival, drivers should park their car onto a assigned pallet in the arrival zone, which is shown in blue in the picture. In considering that gaps in between pallets are not wide enough for all four cars to park at the same time, cars are assigned to park in alternative pallets, in this case, 2 at a time, followed by another pair. Such parallel approach can enhance the parking efficiency, particularly when the stacker capacity is increased to 6 cars or even more. In the departure zone, which is highlighted in purple, driver can pick up their car from the pallet and drive away whenever they are ready. Once all pallets in departure zone are emptied and cars are ready in arrival zone, stacker will descend to the basement and pass pallets horizontally to the lander. Pallets previously in departure zone will also be sent back to the arrival zone at the same time. These landed pallets will be pushed forward together with pallets from arrival zone into the departure zone and lander respectively. Lander will raise the pallets that carry the arrived cars to align with the corresponding level of the stacker. Loading process can also be started at this moment in the departure zone. The stacker then picks up the corresponding pallets from the lander and elevate to the parking bay. The whole loading and unloading cycle can then be repeated. It is obvious that such mechanism is very dangerous to both the driver and cars. There are large holes on the floor and many moving parts around. Therefore, it is necessary to establish garage facilities to protect the people and cars. In the arrival zone, every parking slot is labeled with a letter. Overhead annunciators are installed to notify driver where is the assigned parking slot. Another colored traffic indicator surrounding each annunciator acts as traffic lights to control the access to each of the parking slot. A set of rolling gates are installed at both sides of the lander in both arrival and departure zone. These gates will remain lowered throughout the car loading and unloading process in both zones in order to prevent any cars or persons from accidentally entering the operation area of the lander. When the loading and unloading process finish, there should not be anyone in both the departure and arrival zone. These rolling gates besides the lander will then be raised to facilitate the lander to land the pallets onto the ground and push them forward. During this stage, the other sets of rolling gates at both ends of the garage will also be lowered in order to prevent anyone or any cars from stepping into the moving pallets. After all these pallets movements, all the rolling gates besides the lander will be lowered, whilst the remaining rolling gates can be raised to direct traffic for the next cycle of loading and unloading process in both zones. Right next to the garage is a hydraulic passenger lift that travels between the basement and the ground floor. In the arrival zone, after drivers get off from their car, they can proceed to this lift for exit and confirm that their car is emptied and locked. In the departure zone, another lift in that zone can bring drivers down to the garage for boarding. Please note that this passenger lift shares among the same zone. So as a safety precaution, these passenger lift doors at basement will remain closed whenever the lander or pallets are of that side is on the move or going to move. This prevents any unexpected access to the garage when the lander or pallets are on the move, whilst maintaining normal operation for another unaffected side. Here is the bird's view on each of the basement facilities we have just walked through. In the middle, we have stacker that runs vertically inside the lift silo. Parking bays that store cars on pallets reside at both sides. Further down to the basement, we have 2 identical landers that gently lower the pallet onto the ground. Garages are constructed at both ends of the lander, serving the arrival and departure zones. The hydraulic passenger lift in each zones then commute drivers to and from the ground floor. We can then add the connection roads in both the arrival and departure zone via ramp such that the car park can connect to the outside world. Here is how it looks from the above. Other than connection road, we have reserved some space at both sides of the parking facilities for evacuation purpose. In this design, connection road for departure is very short. This ensures that cars can leave the car park quickly after they are picked up. On the other hand, the arrival path is a lot longer in order to reserve sufficient buffer for them to park on the designated pallets. The next consideration is the evacuation route, particularly from the garages. Among each of these 4 garages, 2 of them locate close to the ramp in both the arrival and departure zone. Let me call them the ramp side garages. The remaining garages are the non-ramp side garages that locate at the opposite side. For each of the non-ramp side garages in both arrival and departure zone, the emergency exit doors will lead them to separate escape stairs connecting directly to the ground floor. The 2 exit doors now appear in the screen are the exit doors in ground floor. The escape route for ramp side garage is a lot straightforward because they are so close to the widely open ramp that leads directly to the street outside. Other than the escape route for people, escape route for cars should also be considered. In the existing design, once the driver drive into the car park, there is no way back. So in case the car cannot be handled by the system due to whatever reasons like overweight, the car will be stuck. That's why this highlighted escape route designed for car come in place. It bypasses the pallet system and connects the end of the arrival zone directly to the ramp, though the turn is a bit tricky. This escape route for car is also forms part of the escape route of the 2 ramp side garages for people. I hope you would enjoy this episode. Whilst I am working on the next innovative design, please feel free to comment and stay tuned. Just before we go, let us take a quick ride into the car park to see exactly how it looks like inside. Thanks so much for your watching, and bye now.